Hello, welcome all. This is Russ again. This is my Java for C programmers video. So this is for those of you who have seen C before in some sort of class outside of this department, and so Java might be a little bit intimidating for you. If you've seen C++, then Java is going to be a very small jump. Even if you've seen C, the amount of Java that we use is pretty minimal. So let's get started here. The first thing, I'm going to look here at actually what I'm going to do is I'm going to bring in a very simple one. So we can just look at the basics Java program, then we'll look at some of the features that we're using in the XOR class. All right, so Java is a language that is derived from C, and so what you'll find is that code that you write in Java is going to look almost exactly like C code. The key difference is the fact that Java is object-oriented, and so that means that everything that Java declares is going to be inside a function. Alright, so here what you have, this is a function declaration in Java. You notice that this looks a lot like a C function declaration. Has the return type, we don't have any parameters in this case. Has the curly braces as you've seen before. This one is marked public, which is just a matter of protection about who's allowed to call this function, who's not. The key here is that you notice that it's inside a class. So this is a member function inside the sim1 and class. Now a class in Java is essentially the same as a structure in C. Again, with the added feature that we can create functions inside of it. And so what you'll notice here, these are a couple of fields. Every time we create a sim1 and object, it will have a couple of fields called A and B, which are both Rust wires, and a field called out, which is also a Rust wire. Now, when we go take a look at what Rust wire is, I'm actually not going to get into the details here, but I will show you that there is a class, rustwire.java, which declares the class rustwire. You don't need to see what a rustwire is. The key, though, is to notice that rustwire is an object. Now, in Java, they have the convention, which is different than C, that all variables that contain references or that contain objects are not actually there by value, they're all there by reference. So this rustwire, it says A and B, these are actually pointers. Our Java calls them references, but for a C programmer you can think of them as pointers. If we had this in C, we would say rustwire star A. Alright, so the thing that you'll notice here is that these are pointers. In Java they default to null. So if we just took this code and immediately tried to access it, we would get a null pointer exception coming out of Java. Now, I will talk to you about how to fill that in just a minute. But right now, let's talk about how to use these fields. A very common thing in object-oriented programming, this doesn't happen in all languages, but very often, is that there is an implicit parameter. So when you see public void execute, there actually is a hidden parameter inside of it. If we had the C equivalent, this would be a void execute method that had a sim1 and parameter. And when you go take a look at sim1.c, where you have to implement the execute add method, you see exactly that. You see a pointer to an object that contains some data values. In Java, all of that is implicit. We get this pointer for free. It's actually called the this pointer. So what we can now do is we can simply access the fields of our object. When we say A equals, what we're saying is, let's access the A field inside of the current object. If you wanted, it actually is legal to say this.a equals something. That's actually the exact same thing. Doesn't accomplish anything different. Now, the trick here is that these are not simple Booleans. So if you try to say A equals true, this is a syntax error. You can't get away with it. Instead, what we're going to have to do, if you go look at the spec, is you have to say A dot set true. And I'm sorry for that syntax. It's clunky syntax, but it turns out that this actually causes less confusion than the alternative of using a Boolean variable. So what this is doing here, when you see this call, is that this is going into the RustWire object and calling the set method on object A. So again, you don't need to know the details, but if you take a look, you'll see that there is a set method inside the RustWire class. So when you say a.set, what you're doing is you are calling this method. It has an implicit parameter, which is here's the pointer to the object that we're currently accessing. And you notice I use the this pointer to refer to that object. But it also has other parameters. Again, we're not going to get deep into it, but I want you to see just enough of what's going on. All right, so what we've got here is that we can access variables. We can also read things out. This is calling the get method on our A object. You'll notice that the variable declarations look just like C. Type, name, equals, whatever. The types that you're used to from C will generally work. You'll be using ints and booleans in these projects, basically. A boolean is basically an integer variable that's constrained to only having the values true and false. When you're writing your code, you can use all of the same constructs that you're used to from C. You can say if some condition, curly brace. If you want, you can have else, or you can have else if, you know. Basically, the core syntax of the language is exactly like what you're used to. One little quirk is that the condition here must always be a Boolean. In C, it's legal to write something like this. Int x equals 0, and then say if x. That is not legal in Java because the condition must always be a Boolean. So if you want to do this, what you say is int x does not equal 0. The not equals returns a Boolean variable, and now it works. The same thing is true for while loops. The same thing is true for for loops. For loops work exactly like you've seen before. Nothing particularly new or interesting. You can use break and continue, just like you've seen before. Allows you to declare the iterator variable in the for loop statement. Depending on what version of C you're used to, maybe you already use that, but it's not required. And use the old-fashioned C style, and it works just fine. So for the most part, that's what you're going to be using in this, in this project. We're not really asking you to do anything terribly complex. We're more focusing on the simulation than the language. Now, the one thing that you do need to do is you need to handle initialization. And so As you know, in C, it's very common to have a function, an init function, that you might call for a certain struct. You might malloc the struct and then call your init function, and it fills in all the fields to the default values. In Java, you're not going to use malloc, and you don't have to explicitly call the function. Instead, what you're going to use is an operator new. If you're from C++, this will be very familiar. If you're from C, what it is it automates all of the work necessary for that you would normally do for malloc. So remember that I said that these RustWire variables are references. They're the Java equivalent of pointers, and they default to null. So if we simply ran our execute method right now, we would get a null pointer exception as soon as we tried to use the variable a. So what we're going to need to do is initialize it, and the place where you initialize it is a special function known as the constructor. You'll notice that this function is slightly strange. It doesn't have a return type, and its name exactly matches the class name. That's actually the definition. A constructor must have those properties. Constructors can have parameters, but we're not going to be using that in this class. Alright, so what's going to happen here is the constructor sets the values of all the fields to whatever their init value is. So we want to say A to something. We want to set B to something. And we want to set out to something. Those are the three fields inside this class. What's going to happen is as soon as we allocate this sim1 and object, Java will automatically call this function and do whatever we've written in here. Now, obviously, if we were doing this in C, if we had a RustWire pointer called A, what we would want to do is we would want to malloc. Right? This is what you would do in C. In Java, we're going to automate that. What we're going to do is we're going to use the operator new. So, what this does is new is the Java equivalent of malloc. This just says pass no parameters to the RustWire. So what it will do is it will allocate a RustWire object. It will automatically call the constructor inside RustWire. And then it will return to you the reference to the newly created object, which we can now save into the variable a. Likewise, we want to do the same thing with out and b. And of course, when we do this, we are creating three different objects, three separate objects. This is the same as if you did three different malloc calls in C. Java has garbage collection, so you don't have to do any cleanup. When this object gets destroyed, these references will go out of scope, and the garbage collector will eventually automatically clean everything up. Not that it really matters, because we're only going to run the program long enough to execute a single step anyway. Alright, now what you will see, if we look at sim1 I just copied that over, that's okay, we didn't have anything we wanted to save. Let's look at add function. Alright, Java has built-in arrays, and so what this declaration is telling you is that A and B are both arrays. They are arrays of the RustWire class. Now, Java does not allow you to simply create an array of objects. That's not how it works. Instead, what you do is you create an array that's full of null pointers. And then, as a second step, you will go through and so here we actually have, you could see an example of it. So we created, this is the syntax for creating an array. Now this is not an array of RustWires. This is an array of references which can be pointed to RustWires. This is in C. If you wanted to do the equivalent, this would be, we would need to say Russ wire double pointer A equals malloc 32 times size of Russ wire. Because remember, Russ wire by itself is a reference to a Russ wire object. Russ wire bracket bracket is an array containing many of those references. So this would be the C equivalent here. Going on here is we're allocating 32 references that can point to Russ wires. We do that for B, we do that for some. This is representing the fact that the A and B inputs are 32-bit inputs, and we have a 32-bit output. But now we iterate 32 times, and for each of those elements in those three arrays, we allocate Russ wires. So this actually creates 3 arrays and 96 wire objects. Now you'll also notice that it has a carryout and overflow object, and so function, notice that it doesn't initialize that. If you try to write your execute method and start using carryout and overflow, you will get a null pointer exception because both of these are initialized to null. This means, of course, that you will need to add code to the constructor to initialize carryout and overflow, just like we did in the add method. Very similar. All right, let's see. That's the key things. We can let me go take a look at on XOR and see if there's anything that we haven't discussed yet that you should be thinking about. All right. This is actually copying wires around. I mostly have gone away from this style, and I would prefer to call set here and get here. But in Java, this is actually assigning a reference. This is no different than in C, assigning a pointer. You're actually saying the A field inside the AND1 object should now point to the same thing as our own A field. So here you can see a number of different objects getting created in the constructor. You can notice here that we have sub-objects. So inside an XOR, we are doing and OR and NOT gates. And so what we did was we created a couple of NOT gates here, or these are variables. We initialize them here, and then they get used up in the execute code up above. What's going on here is that this is something that had to be added by the programmer. I decided to mark this private. It doesn't really matter if you mark it private or public. It's just a matter of good design style in Java. Something that's designed to be an internal field of a class, you mark private so that other people can't muck with it. But we won't mark you down if you mark it public. It doesn't really matter. So here we create all of the objects, and up in execute we use them. You'll notice that that was one of the requirements in the spec, was that execute should not call new anywhere. This is basically modeling the fact that we're thinking of this as a piece of hardware. And so when you look at this constructor, you can think of this instructor as a wiring diagram, or you can think of it like a breadboard sitting on a desk in front of you. And what these are the various steps required to wire everything together. So we've got a NOT gate, and we have to plug it into the breadboard. What the execute method represents is that this is the actual flow of electricity. So the A input that goes into our component becomes the input of one of the NOT gates. The B input flows to one of the other NOT gates. then both of those NOT gates will use those inputs and actually calculate some sort of an answer, and their outputs become inputs into other gates. And so what we're modeling here is the flow of information through a piece of hardware. That's why I made the distinction of you can create objects here in the constructor. You can create as many objects as you want. But in execute, all you can do is model the flow of information between them, moving back and forth. All right, so I think that's everything you're going to need to know to work in the Java projects. If you've got any problems, any particular difficulties, be sure to talk to me early. My whole thought here is that I don't want to make this complex. I want to make this understandable to help you learn how the hardware works. So, ask what you need. I'll see you in class.